Okay, so in this video, we will solve problem 9e from problem sheet number 5. If you recall the setup, from a deck of 52 cards, and here we've arranged the cards according to their suits and their kinds. First with the aces, thinking of a hand of poker, the ace being the strongest card. There are a total of, well, 4 suits times 13 different kinds, so 52 different cards. And out of those 52 cards, we are dealt 5 cards at random. As we've said before, because we clearly have here a setup that is unordered and without replacement, we can use our knowledge of combinations, and we can start by reminding ourselves of how many total possible hands of 5 cards can we be dealt in total. Well, out of 52 cards we choose 5, which gives us a total number of 2,598,960 different possible hands of 5 cards. And out of all of those possible such hands, we want to count only those that have exactly one pair. So when we say one pair only, what we mean is one pair and nothing stronger. Before we count all such pairs in general, we start with a specific example. So we are dealt 5 cards at random. So a pair of what? Right, could be a pair of 2s, 3s, up to aces. Say we have a pair of 9s. Well, which 2 9s, right? There are 4 9s available. The 9 of hearts, diamonds, clubs, and spades. Let's pick 2 at random. Say we have the 9 of diamonds first, and then the 9 of clubs. Now for the remaining 3 cards, we can get a 9 again. This would be a triple, so the 9s are out. Say we take a queen, and again, which queen? We have 4 possibilities, right? Say the queen of hearts. So far so good, we are respecting the one pair only. The 4th card can be a 9 again. This would be a triple, too strong. It can't be a queen either. This would give us a 2nd pair. So the 9s are out, the queens are out. Say we have a 4th pair that is a king. Again, which king? There are 4 possibilities. Say it's the king of spades. And for the 5th card, because we again want a pair only, well, this card can be a king, that's a 2nd pair. This card can be a queen, that would be again a 2nd pair, and this card can be a 9, this would be a triple. In each case, a stronger hand than one pair only. So the 5th card can be anything but the 9s, but the queens, but the kings. Say it's a 5. And again, there are 4 possible 5s to choose from. One of the 4 suits. Say it's the 5 of diamonds. So now we have such a hand of 5 cards that contain one pair only, so one pair and nothing stronger. No other pair or triple or quadruple. One pair and nothing stronger. Let's now go from the special example to counting all such possible hands of 5 cards in general. And we'll just go over the specific case and extrapolate the general argument. Well, first, which pair do we choose, right? Is it a pair of aces, pair of kings, pair of queens, up to pair of 2s? So this is a selection from the kinds, right? Is it a pair of aces, kings, queens, up to 2s? So out of 13 different kinds to choose from, we choose only one kind. We choose only one pair. So we choose either the aces, the kings, the queens, and so forth. So 13, choose one. This is of course 13. Either way is fine. Say we've chosen now a pair of 9s. So now we have the kind of our pair, 9s. Well, that's not all, right? We have to specify the suit. So how many suits can we choose from? Again, there are 4 distinct 9s, 1 for each of the 4 suits. Out of these 4 possible 9s, we choose 2. We choose the suits, so there are 4 choose 2 different pairs of 9s. Now we have counted the total number of possible pairs. But that's not all, right? Our hand now is incomplete. We only counted the number of possibilities for our first pair, and times we have to count the number of possibilities for the 3 remaining cards. And here's where you have to be careful. These cards cannot be of the same kind as the one we chose initially for the first pair. So initially there were 13 kinds to choose from. Since we can no longer choose a card from the first kind that we chose, so the 9s are out. This rules out one kind to choose from, so we're down to 12 kinds left over. So the 9s are out, but any other kind does the trick. And because these have to be distinct, out of the 12 left over available kinds, we have to choose 1, 2, 3 of them. And again, it is without replacement, because if you choose a queen, you can't pick a queen again. This would give you a second pair. And so because these have to be distinct, we have to use our combinations, because we have here a selection without replacement. If you say that the kind of the third card is a queen, queens are out. So when you choose the kind for the second card, you can't pick the 9s, can't pick the queens, you're down to 11 kinds to choose from. That's why here there are 12 choose 3 ways of selecting the kinds of the remaining 3 cards. But we're missing the suits, right? Each card has a suit. So, and how many possibilities, once we choose the kind of the third card, how many possibilities do we have? Well, out of the 4 queens available, we choose 1. Of course, you could say, well, this is obvious, right? There are 4 queens to choose from. We choose 1. 1, 2, 3, 4. There are 4 possibilities. So times 4. You can also, of course, write 4, choose 1. Same thing. But we're not done. We have to choose the suit of the 4th card. And how many possible kings can we choose? Well, there are 4 kings to choose from, and we're choosing 1. 4 C1 possible kings, which is 4 again. And we have to choose the suit of our 5th card. At 5, there are again 4 different 5s to choose from, and we're choosing 1. Again, 4 choose 1. 4 different possibilities. And now we have a complete solution. We've chosen the kind of the first pair, then the number of possible suits, and the kinds of the remaining 3 cards. Because it had to be distinct from the first kind, we were down to 12 kinds to choose from. We chose 3. They had to be distinct, combination. And for each of the last 3 cards, 1, 2, 3, there were 4 possibilities for the suit. Times 4 times 4 times 4, or 4 choose 1, 4 choose 1, 4 choose 1. We can write this more concisely. 13 choose 1, of course, is 13. 4 choose 2. 12 choose 3. And again, 4 choose 1 is 4. This is 4 times 4 times 4, 4 cubed. And if you calculate this with a calculator, you will obtain 1,098,240. So out of the total number of possible hands of 5 cards, which is approximately 2.6 million, approximately, or exactly, or I could say approximately 1,100,000, roughly, consists of a hand of 5 cards with one pair only. So one pair and nothing stronger.